Hello, the next experiment in the series we will be doing is experiment number 11 for General Chemistry 101. The title of the experiment is the standardization of a base. The base that we will be using is NaOH, or sodium hydroxide solution. The sodium hydroxide solution is titrated with using a standard material. The standard material used is potassium hydrogen thalate. The potassium hydrogen thalate is called as a standard because its mass is known exactly. It does not have water of hydration crystals in it, water of hydration molecules in it, and it is very, very stable. So once we know the amount we have taken, then we can find out the moles of the acid that is there in the solution that is to be titrated with the unknown base for whom you are determining the standardization. In order to find out the endpoint, there are two methods to be used. One is include the pH meter inside, and at the same time, we are going to add an indicator. An indicator is an organic substance which has color, one color in the acid medium and another color in the base medium. And therefore, we can find out when exactly the experiment is concluded, or the endpoint or the acid is completely neutralized. However, because we are adding the pH meter into the system for the reaction, we will continue to take a few more extra points and then use the pH meter reading to find out where exactly. On one side, you will use record when the color changes, and the second time, you will record it from your pH meter graph to find out where exactly the neutralization occurred. Once you know the volume of the base that is required, then we know the moles of the base acid, and we can find out the moles of the base by saying that 1 mole of acid is equal to 1 mole of base. And because this mole is in solution, we can say molarity times volume in liters will give you the moles. And if you know the volume in liters, then mole divided by volume in liters will give you the molarity of the base that is there. Once the molarity of the base is known, then you can find out how many grams of the solute sodium hydroxide was added and what is the percentage of the solute in the solution. And with that, I'm going to share my lab, my screen, and the lab. And so I'm going to click it there. I'm going to open the Chem Module Lab. Same procedure, every experiment follows the same setup. Open the Chem Module Lab, go to the standardization of NaOH solution, and there you have it. Whatever I have talked about in the introduction, you can read it, write it down in your own words. At the endpoint, we will have moles of NaOH is equal to moles of KHP, molarity times volume. For NaOH is equal to moles of NaOH is equal to molarity, moles of KHP. Moles of KHP is obtained by dividing grams of KHP taken by its molar mass. Once you know that, you can find the reaction. This particular setup is done twice, one with a known molarity solution, and another time the same experiment is repeated using an unknown solution. I will just demonstrate the known solution experiment, and you can follow the same steps for the unknown, and then get the graph, everything, which I will demonstrate. So now for the procedure, it says you weigh. So first get an Erlenmeyer flask, and into it you add 2 grams of potassium hydrogen thalate. Add 100 ml of water and 2 drops of phenolphthalein. Then we'll fill up a burette with a base that is there of 0.3 m and record the initial volume of NaOH in the burette. Then you add a pH meter into the flask, turn on the collection data, and so on. So here, I'm going to show it. So first, we are going to get an Erlenmeyer flask, 250 ml Erlenmeyer flask. Into this Erlenmeyer flask, we are going to add potassium hydrogen thalate. Again, the same rule. I'm just going to add whatever I want, but you please follow the instructions. Follow the instructions so that you don't mess up. And then I'm going to add that. Then I'm going to add 100 ml of water into it. And then I'm going to stir it up so that all the solid KHP is dissolved. Once it is dissolved, I'm going to just shift its position so that I can get a burette, a 50 ml burette. And here is the titration dialog box. Here is the burette. And I'm going to add, from the chemicals, I'm going to add the 0.3 m sodium hydroxide, 50 ml, so that the burette is full with the solution. And there you go. And into the flask, I'm going to add phenolphthalein indicator, about say 3 drops. And so it will tell you in the procedure how many drops you have to add of the indicator. And into the same flask, I'm going to add the pH meter. So now you have the pH meter, the indicator, and the titration dialog box is there. And then I'm going to click on the flask and say, collect the titration data. Then I'm going to right click again and say, I want to view the data. So here is the data. So this is the data that you will get. And if you want to copy it, then you just, after the experiment gets over, you can say, copy the graph and then put it in your experiment. So here, remember that the burette is filled with 50 ml of base, but its starting point is 0. So you enter it as 0, 0.00 ml, and then open the valve, stopcock, and you can see as the titration proceeds, you will see the burette volume is decreasing, and you are getting a reading at the bottom on the titration curve. You can see that the pH is almost steady and there is no dip in it. It is just gradually increasing because the amount of acid is much more than the base added. And when there is the complete neutralization occurs, color will change on one side and the pH meter reading will go up on the other side. And so you have to keep your eyes open for both those instances, watching carefully. You can see that the pH is rising now. There you can see see now you can see when at what volume the color changed. You can write it down, but you see you record that volume here when the color changed, and then you have to continue to add a little bit more of excess because this is a half graph. Since we see that it rose suddenly and sharply, but we don't know where it's going to end. So the reading for the initial is 24.7, and then you open it again and let the experiment continue with its draining of the burette so that you get a symmetrical graph in the shape of an S curve. And once you get the S curve shape, then remember that the color changed at 24.70 in my case, and we are still continuing to add to make sure that the symmetry of the graph is maintained. It is very, very important to maintain the symmetry of the graph so that you can get the midpoint accurately. Once you see that it is symmetry, you close the graph, and now we can copy this graph and paste it. Now, at the neutralization point, the pH will be 7. So you just use your ruler and then plot it down below and see where exactly it hits the titrant axis. Now, how do we find where exactly is the midpoint? So you make sure that the straight line portion is used to measure the volume. So this is how you calculate. Once you know the volume, then you can follow the procedure. Calculations, write the observations down, complete the calculations, and then do the same thing for the repeat. Make sure that you copy and paste the graph. So you can you go to edit, copy, and it will allow you to paste. Now, on the other hand, if you want to view the data, then of course you can go here and you will see the mLs of NaOH added and the pH recorded. And you can also go through this whole screen and find out where exactly the pH changed. So at 25.5, the pH was at 24.4, the pH is 3.6. At 24.5, the pH has become 9.6. And so that the sharp jump is between these 2 points. And then we got it at 24.7. And so it's about 10.7. So you read that accurately and you can find out. And with that, I'm going to stop my share since I've shown you everything. And you can continue with the calculations.